Yowzers, we are back. We've got bandwidth issues. We're going to get through it anyway. Here's the sun in colorized magnetogram. And 171 angstroms from the SDO, the Solar Dynamics Observatory. 2 major sunspot groups. This one here is alpha class, last I checked. This one here is beta class, last I checked. And likely to produce major solar flares, hence our solar flare warning. Coronal mass ejection warning also in effect, as there are additional CMEs about to occur in the earthly region. They might not be earthly directed. The one yesterday wasn't earthly directed. It was not earthly directed. It was off to the west. And you can see some activity coming out of sunspot 2880. It's this region up here in the part of the imagery that we have. You can see a bit of a plume of plasma coming out of that. Continuing on to the colorized magnetogram. Again, looking at the available data. Again, sunspot 2880 still capable of producing major flares, and the closer it gets to the limb, the more likely it is to produce a major flare detectable from Earth. The 10.7 centimeter radio flux, the radio emissions from the upper chromosphere and lower corona, now down to 84. Here's the 1-year chart of that. The black line is the radio flux, the red line is the sunspot number. The 10.7 centimeter radio flux is the most proportional data set to sunspot number. Here's a space weather enthusiast dashboard. No space weather storms in the forecast. Looking at global seismicity real quick. Looks like a little bit of an uptick here. So there was a 5.3 at Indonesia, a 5.1 at the South Sandwich Islands. Looks like nothing over a 6 magnitude. Fiji saw a deep quake at 4.9. That was over 500 kilometers depth. Peru saw a deep quake at 4.7. Afghanistan saw a deep quake at 4.6. Bolivia saw a deep quake at 4.4 magnitude. That's 264 kilometers depth at Bolivia. And Switzerland saw a 4.3. That's pretty rare. Closing out the list with a 4.4 in Indonesia at over 120 kilometers depth. Volcanic uptick continues, folks. Now, Krýsuvík in the southwestern portion of Iceland produced more than 1,000 quakes, as well as a 4.2 magnitude quake on October 2nd. Let's see what else is on the list. La Palma appears to have consolidated its lava lakes. 2 to 3 kilometer ash plume rose, and lava flows continue to advance, both at the sea entry and widening of some of the margins of the existing flow field. So here's a little clip from La Palma. Quite a large volcanic system there. Luitolo also erupting in the Lesser Sunda Islands in an explosive fashion, producing an 8,000-foot plume of volcanic ash. Kilauea continues to erupt. It's the Halima Uma'u crater, not to be confused with Pu'u'o'o crater. Lots of lava accumulating in the lake at the base of the crater. Lots of sulfur dioxide, although emissions have decreased. Fuego exploding, 15,000-foot ash plume over Guatemala from Fuego. Nevado del Ruiz, no volcanic ash observed. Don't assume it's not erupting. Don't build a campsite at the base of Nevado del Ruiz. Sangay exploding, 19,000-foot ash plume over Ecuador. Revenador producing a 16,000-foot ash plume over that same country. Sabancaya, 25,000-foot ash plume over Peru. Please don't pole vault the caldera. Please do visit our links. Pick up some merch. I'm currently wearing the Mensa hat, where I invite you to make Earth not suck again. Yes, make Earth not suck again, folks. It's up to you, not giant bureaucracies and ineffective bureaucrats and hack frauds who can't get out of their own way. It's up to you to make Earth not suck again. It's up to you to make America not suck again. So Mensa, Mansa, pick up the merch, join the Smash team, etc. We're also on BitChute. Check it out, over 1,000 views on yesterday's meteorology segment entitled, "The Galaxy, the Sun, the Jet Stream are all gonna kill us all." The propaganda, that's fine. Yeah, okay. Don't forget to press like and subscribe if you enjoy the content on YouTube. Tell your friends and foes about the channel. I don't think the algorithms are doing it. And haha to Facebook. We hope your stock price reaches $0.00000000001 per share, and that all your servers mysteriously catch on fire. By the way, patrons, please cancel your Patreon and become Smash Team members. SmashoMash.com/Smash Team. Thanks to our patrons, by the way, who made the Smash Team possible. Come over to the Smash Team and continue to get the full story. You're not going to get the full information on YouTube videos or on BitChute. The only place you'll get all the information is at SmashoMash.com/Smash Team. There's a sneak peek. That's all you get in the month of Smashtober, as it's a very scary month. So welcome to the Neo Renaissance, folks. Visit SmashoMash.com. Click our links, the Smash merch. We showed you the link from that. There's also a forum. And there's a link to the Smash team, both in this graphical link and up here in our header. Click the header links. By the way, we did a 7-hour and 40-minute stream last night of the sun on Twitch, twitch.tv/SmashoMash, for your best solar current solar screensavers. Let's get into magnetic data and continue on in the realm of space weather data. So we're seeing some wild spikes here happening in the magnetometer data, and there's a magnetic tug-of-war going on at the moment with the solar plasma. It's indecisive as to which polar field will be in charge. I'm saying the South Pole field could come through here. We've also got some trans-equatorial North Pole-oriented coronal holes, and these are affecting, as well as the sunspots, of course, the readings on the GOES magnetometer. That's all I can really tell you without getting into a long, in-depth explanation with graphics. But there's 3 days of GOES magnetometer as measured by the GOES 16 and GOES 17. Here's the top view ecliptic plane field plot, part of the National Sunspot Observatory. This data is based on 51 ground-based magnetometers and magnetometers on stereo A out here at Lagrange point 5 and stereo B here at Lagrange point 4. You can see there is a bit of South Pole current sheet showing up there in red, although the Earth looks like it is rather solidly in a North Pole current sheet. So I won't make any conjectures about that. I'll just show you the rest of the data. Here is the line of sight view. It also shows you the solar magnetogram. That blue line gives you an indication of the BZ portion of the solar wind data. Anyway, here's the latest image. Keep in mind that data's an hour and 13 minutes old from when we recorded the video. Here's the line of sight coronal hole plot showing you the sun's B field. Also, those blue lines, those are the sun's potential field surface source lines for the sun's B field. And you can see this large North Pole-oriented green-colored trans-equatorial coronal hole here stretching way down into the south. We'll be keeping an eye on that. And when I say eye on, well, the pun is intentional. So can we get any really visuals of that? Not so much. Just realize that there are North Pole-oriented coronal holes around this area, and they will affect things in terms of magnetism. The Integrated Space Weather Analysis Center, or ISWA, has a flare monitor. It's the first item on the first tab on solar. The likelihood of major solar flare is still quite high as a result of sunspot 2880. It's still beta-gamma class sunspot, and as it approaches the limb, it becomes more and more likely to produce major solar flares. Having a little problem with mosquitoes flying around here at the Smash News Network. Next, looking at solar flaring over the past 3 days. No major flares. Solar flare warning in effect because of sunspot 2880. No spikes in the proton flux either. No relativistic particles striking the geospace lately. Let's look at the real-time solar wind next. And we do have some questionable data here. We see this really extreme downtick in the solar wind density there, which raises the possibility of errors. That's what these red and orange bars are down here, folks. Current conditions are Solar wind density about just under 8 protons per cubic centimeter. Solar wind speed below 300 kilometers per second. Extremely slow solar wind speed. KP index, a measurement of global geomagnetism, at 3, which is actually surprisingly high considering such a slow solar wind. And here's magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework over the past 4 hours. And like yesterday, we're primarily seeing pressure on the magnetotail side, the non-sun facing side of the planet. The magnetotail side of Earth, which would be on your screen right, and fairly homogeneous pressure on both sides over the past 4 hours. Here's the ground magnetic perturbations showing you changes to Earth's B field known as geospace delta B. Again, 4 hours of data. And we see some pulses coming out of the Pacific Ocean. And we typically do around this time of year. We've documented it over and over again. It's got something to do with the Earth's internal structure. Next, looking at the solar system structure. By the way, tomorrow's Smash Staff's birthday. Make sure you wish Smash Staff a happy birthday on 10/6. Let's advance this 1 week. There's where things will be in a week. Mercury will be past us in its fast orbit around the closest star. Here's a star chart. Mine's facing to the south. We've also drawn on the ecliptic, which is the yellow line, and the galactic plane, which is the blue line there. It's in-the-sky.org if you want to make your own. Today's cosmology segment will be brief. Check out the astronomy picture of the day. The slowly rising sun coming out of winter in Antarctica. Yes, not many people stay there over the wintertime. And if you'd like to go stay in Antarctica, well, you pretty much have to be multi-skilled, and you have to have a quality back, because if you can't shovel snow, you can't winter in Antarctica. They have to shovel snow like nearly every day, or they'll get snowed in and they'll die because they won't be able to get out of their buildings. Anyway, there's a bit of air glow there caused by a lensing effect of the Earth's atmosphere. It's not because Nibiru is over the North Pole of the Sun or anything like that. That's the astronomy picture of the day. You can check it out yourself at apod.nasa.gov. Today we're not going to look at any random objects or anything at the Neil Gorell Swift Observatory. We're going to look at cosmic rays. And we've seen an increase in cosmic rays here over the past week at all of the reliable monitors. So here's UpptICK. You can see this uptick. Still a downtick over the past 30 days, though. Barentsburg showing nearly the exact same graph, an uptick over the past week and a downtick over the past 30 days. But that recent uptick making it almost flat. Let's go farther south to Athens, Greece. You can see that similar uptick at Athens, Greece, enough to make it an uptick over the past 30 days at Athens. How about even farther south to Mexico City? Mexico City now rather flat on the past 30 days. And a similar uptick in the past week. Not quite as steep. Let's go back up farther north to Oulu, Finland. Another reliable cosmic ray monitor that I actually trust that doesn't produce a lot of nonsensical data. And there's Oulu. Less of an uptick there at Oulu over the past week, but enough to make it flat over the past 30 days. We'll also look at the farthest south monitors we've got, DOMB Antarctica. There's DOMB. Also an uptick over the past 7 days. An indication that it's legit data, unlike a lot of the crap I see people posting about cosmic rays on the internet. And here is DOMC Antarctica, another reliable and believable cosmic ray monitor. Anyway, that's today's cosmology segment. If you've watched the videos in the past, you are aware of the importance of cosmic ray flux. It does all kinds of things to things like climate and even things like human health, spontaneous evolution, and all kinds of weird stuff going on. Computer errors. Veritasium recently did a video about it. Check our other cosmology segments. There's a whole playlist for them. Over 200 videos at youtube.com/smashamash/playlists in the cosmology segments playlist. Let's get back to space weather data. Some minor charging hazards here over the Caribbean, northern South America, and places like Florida, about to move into central Mexico, and so on. Here's a 1-year chart of the electron flux, which is typically causing the surface charging hazards. Pretty low levels of electron flux here, and we can expect to see an uptick in the electron flux in the coming 36 hours. So here's the 3-day chart of the GOES electron flux measured by the GOES 16 and 17. Still pretty low levels, and you can expect these to increase to warning levels soon. So I would disagree with this forecast. I'm expecting these to be up quite a bit higher here in the coming days. That's the relativistic forecast model by NOAA and the alteration by me. Here's your diagram of Earth's Van Allen belts. Most of those electrons come from the inner Van Allen belt. And here's the total electron content forecast. This will show you where GPS errors are most likely to occur, which is typically around the equator at noon. And yeah, it's a total electron content. The electron density from your GPS handset to your GPS satellite. Continuing on, here's a diagram of the atmosphere, another one. Distances are in kilometers here to show you where the F ionosphere layer is located at 300 kilometers of altitude. Here's the vibrational frequency. There's a lot of chemical reactions going on at this portion of the atmosphere, folks. In many ways, it's the bridge between space and Earth. And those chemical reactions cause all kinds of vibrations. There are a lot of free electrons, hence the name ionosphere. Also positively charged particles. Anyway, also neutral particles. But the important ones are the ions. Anyway, some significant high-frequency anomalies showing up here. Here's the latest image. That's 7:30 Universal Time. And here's the anomalygram. You can see lots of blue-colored areas as well as some red-colored areas, so some serious low-frequency and high-frequency anomalies there. This is departure in megahertz from the 30-day median. Quite a lot of ionospheric anomalies here. Keep in mind the resolution is only 1 megahertz, which is 1,000,000 vibrations per second. There's the latest image, 7:30 Universal Time ionogram, 7:30 Universal Time anomalygram. Another great meteorology segment aired before this daily space weather video. If you didn't check it out, check it out. There's a playlist for it, youtube.com/smashamash/playlists. Let's look at our ground-based solar observatory at Lermonth, Australia. And there's the hydrogen alpha imagery. I'd like to say once again that our coronal mass ejection warning is still in place, as well as our solar flare warning. So there will be more coronal mass ejections in the earthly vicinity. We only forecast them on the Earth side of the disk and around the poles. And waiting for our high-res imagery to load, we see that sunspot 2880 has certainly degraded. It's still capable of producing major flares, though. And sunspot 2882 has got some more umbrae growing to the north of it here, an indication that it might produce major flares. There are the fields of sunspot 2880. Again, still capable of producing major solar flares, folks. And now this one is more likely to produce major flares because of this new umbra up here. Now, that'll probably be named a different sunspot, but that is close enough to this large sunspot to interact with it. We're closing things out here at 171 angstroms. There is your imagery from the Solar Dynamics Observatory in my favorite wavelength. Congratulations on being my favorite viewer. You're all my favorite viewer, folks. You're all tied for my favorite. So seriously, thanks again, once again, for tuning in, folks. Congratulations on realizing our channel exists, and may that solar wind be at your back. Oh, and happy Smashtober.